Okay, I have a few examples that are a little different. They're similar to the back of the worksheet, but I wanted to give you some extra examples. So here we have on number 1, 27x cubed plus 343 equals to 0. And what we're going to do is solve each of these equations. Now if you go back and remember, we're still factoring, and we're looking for a common factor, which I don't have here. I'm looking at this and I have a sum of cubes, and I'm not sure if you remember about the sum of cubes, but it's just in a shorthand for those of us that were in class. It's written somewhat like this. You have a plus b, and then you're going to SOPs, square, opposite, product, square. Square, opposite, product, square. I'm not going to write those words out, but you may want to. Square, opposite, product, square. Okay, let's go back and look through that. That's just a shorthand version of what we do. We look right here and say, these are cubes. These are perfect cubes. And the question is, what cubed gives me this? What cubed is 27 will be 3. What cubed is x cubed is x. Plus, what cubed gives me 343? 7 cubed gives me 343. So then we're going to square, opposite, product, and square right here. That's going to equal to 0. We're not going to go back here. We're going to ignore this part right there just because we're not going to use it, and sometimes it's easier if you cross it out so you won't go back to it. Here's what we're going to use. We're going to square this first number. 3x squared is 9x squared. We're going to take the opposite sign of plus, which is minus. Now we're going to find the product of these two. 3x times 7 is 21x. And then always add the square of the last. 7 squared is 49. So I have this binomial times this trinomial now. Those are going to give me my answers. Now if I go back and I look, this is a cubed right here, and it tells me I'm going to have 3 answers. The first answer that I have is going to come from this right here. 3x plus 7 is equal to 0, and you're going to solve that. 3x equals to negative 7, so x is negative 7/3. There's one of my answers right there, negative 7/3. Then we're going to take this trinomial, and it's going to be pretty bad because the numbers are big, and we're going to use the quadratic formula for this. It will never bottoms up for you, so you're going to have to complete the square or use the quadratic formula. So here's what we have, that a is 9, b is negative 21, and c is 49. So now I'm going to find d. D is the discriminant. We find that by going b squared minus 4ac. So d is equal to negative 21 squared minus 4 times 9 times 49. So that's negative 21 squared minus 4 times 9 times 49. Multiplying that out, I get a very nasty number. D is negative 1323. So I kind of need to go over to the side, and that is pretty bad, and see if there's a square root of negative 1323. Now because it's negative, I know that there's going to be an I. When I look at it, I know that 9 will go into that. And I'm going to say negative 9 times 147. 7 will go into this. I know the square root of negative 9. 7 will go into that. I know 7 will go into 14 too, and 7 will go into 7 once. Then I can break that on down, and that's 7 times 3. So here's what I have. I do have some perfect squares in here that I have to kind of play with. Some of that old algebra. So I'm going to put that back in my equation. X equals opposite b plus or minus square root b squared minus 4ac all over 2a, and that's 2 times 9. So here's what we have. We did all of our legwork over here to the side. So we have 21 plus or minus, and here's what we got to glean from this square root. 3i times 7. 3i times, I have a pair of 7s, it's going to leave that square root of 3 right there. So this is 21 square roots of 3. That's what I have right here. 21i, make that a little better. Well, there we go. 21i square roots of 3 all over 2 times 9, which is 18. That has a common factor of 3. All 3 of these have a common factor of 3. So I'm going to take that common factor of 3 out, and I'm going to write it over here with my other answer. So here's one answer, and here's the other 2. That x equals 7 plus or minus 7i square roots of 3, and 3 will go into 18 6 times. So if I'm looking for those 3 answers, they're right here. Here are those 3 answers that I found. And that cubed reminds me that I'm going to have 3. So whenever you have the sum or difference of cubes, it's going to be very involved. So kind of get ready for that. This next one, I'm going to pull up. On this next one, example 2, again, I'm going to look at a binomial. So here I have 16x to the 4th minus 81. I want to set that equal to 0. So I have 16x to the 4th minus 81 equals to 0. Positive on the right means negative on the left. Now this is a difference, but it's not of cubes. It's a difference of squares. So notice again, we didn't have a common factor. So I'm going to set up my difference of squares equal to 0. I know my signs are going to be different, and I'm asking what square gives me this. It would be 4x squared and 4x squared. What square gives me 81? That would be 9 and 9. So now I'm going to set each one of those equal to 0. So I have 4x squared plus 9 equals to 0. And I have 4x squared minus 9 equals to 0. I'm going to solve these for x. So I have 4x squared is equal to negative 9. And I have 4x squared is equal to positive 9. Still solving for x. Divide by 4. So I have x squared is equal to negative 9/4. And x squared divided by 4. X squared is equal to positive 9/4. Now if I go back and I kind of look right here, this right here tells me that I'm going to end up with 4 answers. So that's going to kind of key you off right there. This is going to be 4 answers, and that's my degree also of this binomial. When I get down here and I have this squared, how do you undo a squared? You take the square root of both sides. On both of these, to undo the square, I'm going to take the square root. So x is equal to, remember that you can write this as the square root of negative 9 over the square root of 4. The square root of negative 9 is 3i. The square root of 4 is 2. But when you take the square root of both sides, don't forget plus or minus. Plus or minus 3i over 2. This again is the same as the square root of 9 over the square root of 4. The square root of 9 is 3 and the square root of 4 is 2. So I have x is equal to plus or minus 3 over 2. So here are my 4 answers. Positive and negative 3i over 2 and plus or minus 3 over 2. 1, 2, 3, 4. So it's a little more involved. Of course, we're progressing algebraically. So these are my 4 answers, and I had to go through this method to get there. One thing you can look at, you can factor this one again, but to solve it for x in this manner is really the easiest way to work it.